Hello and welcome everyone. Welcome to another ConsenSys Cypherpunk Hackathon workshop. We're here with Dan. He's going to be doing another one. He already did one, and great to have him back again. We're talking about EIP 3074 and improving your Ethereum wallet. So talking UX here. This is great. This is going to be an excellent topic to discuss. I'm sure a lot of you guys are really interested in this. Just quick housekeeping on Crowdcast, which is the platform we're using today. On the right-hand side there, if you haven't been here yet, if you have, you'll probably have heard me say this a few times on other workshops. But we have the chat on the right-hand side. You can chat with us. You can certainly ask questions there. However, if you'd like to have Dan officially answer your question and get that on his radar, go ahead and add it to the ask a question queue at the bottom there. Now, if you type, this is a cool feature of Crowdcast, if you type in the chat and you put a question mark before you hit return, it'll pop up a little orange button that says, would you like to add this to the queue? So that's kind of a neat way to add the question as well. If there's questions in there and other people you see, oh yeah, I really want that question answered too, you can upvote it. And that will give us a sense of, the priority. Of course, we usually get to all the questions by the end of the workshop, so don't you worry. As well as there is a green shiny button there that says see more workshops and sign up for the hackathon. So of course, we would love for you, if you're inspired, if you have an idea after this workshop, maybe you're inspired and you want to actually hack an idea and give it some life, give it some legs, please sign up. We'll help you put together a team. We'll guide you on how to participate in the hackathon. So don't worry if you haven't had experience, but use that form that's on that document. It's a Confluence doc, has all the details of this event, and you can sign up there. You can also RSVP for more workshops. There's a bunch more that are great. You want to check those out. Of this one and all the workshops are always available for replay at the exact same link that you RSVP, the one that we're looking at now. This will be available for replay, and we'll be sharing Dan's slides so that you can also check those out. Please join us on the ConsenSys Hackathon 2021 channel, Slack channel. So that's where all the replay links and all the slide deck links and all that good stuff is posted, and we'll keep you in the loop on all the dates. So without further ado, I'll hand the mic over to Dan.
Cool. Yeah. Thanks so much for the intro. This is a clearly awesome series to have available to everybody. I can't wait to watch the videos that I didn't get to attend in person. Cool. So so I'm going to be talking about EIP 3074. I'm going to kind of cover it from the very beginning. So if you already know it well, then you might hear some things at the beginning, and then here, let me.
Yeah, I was gonna
do
say,
the actual. Okay. So sorry, I'm
okay.
Dan Finlay.
No worries.
I'm Dan Finlay. I'm a kind of lead over at MetaMask, and I got into this because I wanted to make some cool dApps, and then I was like, oh no, we need a wallet, and then that blew up. So there's a lot to do on a wallet. So we're very busy, and we're always looking for ways to make the user experience better. And 3074 really stood out to me. It's addressing some real challenges. So I'm going to talk a little bit about.
Dan, can you make that full screen? Sorry to interrupt. Can you make this full screen so it's a bit more easy to read?
I cannot easily do that because I'm only sharing a window right now.
Gotcha. Okay, so
yeah, sorry about that. Just bear with. I'm just gonna do it this way. And the truth is, I'm not going to be showing a lot of this anyways. I'm
okay,
be sharing,
no problem. No worries. All right, you got it.
Cool. All right. So I'm gonna summarize 3074. I'll even talk a little bit about some of the alternative approaches to the problems it's trying to solve. Then I'll highlight some of the key. It's been a little popular to talk about the security properties of this, and there have been people who say we shouldn't do anything that's affecting accounts unless it's secure. How do we know this is secure? I think that there's an easy way to reason about the security of this, and I'll step you through that. And then we'll talk a little bit about what MetaMask is doing and what we think we can do uniquely among the wallets to utilize this feature in ways that no other wallet can, and in ways that can really empower the community. And then we'll talk a little bit about how this might make a good hackathon project. This vid talk is part of internal ConsenSys hackathon series, so we'll talk about possible hackathon projects, maybe get you on the team, and then we'll have some open Q&A time. So if you have any questions during the talk, if it's a clarifying question, hopefully I'll see it and I'll answer it on the fly. But I think we'll probably have like, I don't know, almost half the time at the end to like you can like come up on stage and like we can briefly talk about different use cases or concepts about it. So that's where I'm hoping to go with this. So onto the content of the talk. I'm not really big on using the slide deck, sorry. So what I'm going to do is I'm going to start by, so let's talk about like, the motivation and I'm going to start by talking about motivation. So this EIP was motivated originally by the desire for, I'll go to that. Yeah, they wanted meta transactions. They wanted native meta transactions for the ecosystem. And the problem with meta transactions today, you might have noticed the only things that support meta transactions are either dApps that were designed to accept signed messages, so the contract being customized to support it, or cases where the user's account is actually itself a contract, in which case it can interpret an off-chain message and then forward it as if it were a normal message. But if you want to interact with a contract that wasn't designed for meta transactions, and you have an account that wasn't made for meta transactions, then you're out of luck. There have been a couple different approaches to addressing that. Actually, last year I was part of, at MetaMask, we hosted a hackathon about trying to address this. And we were coming up with ways of doing it at the app layer. Like, is there a standard way that every dApp could opt into a generalized meta transaction pattern? We perceived that as more likely to get included because there were no easy proposals for integrating meta transactions for all accounts into the protocol layer. The previous best EIP for achieving that goal formerly was by Nick Johnson. He had a proposal where it was basically that every account could, as a transaction, you could basically execute some code first in the context of your own account. And that would let you do things like assembling batched transactions and stuff like that. That's, I think, still a really interesting idea, but it's a much more complicated idea. And so implementing it safely and defining the semantics of it is a lot more delicate. This EIP takes a different approach. Instead of having a specific new capabilities in the protocol, instead of adding batching, there are other EIPs that include adding batching at the protocol layer as a new transaction type, or adding gas sponsoring or expirations, right? There's scripting is the one I mentioned. These are lots of different features we'd like to add to transactions. This EIP basically provides a generalized framework for adding account features to any and every account. If you have a key-based account, an external account, this EIP gives you a way of delegating your account's power to an arbitrary contract. And if that sounds scary, then you know what people's security concerns might be. So let's look at it. The important thing is, okay, so this magic constant is just used as a signature prefix. It just means that signatures, when we talk about a 3074 signature, it has a special prefix, and so we're not concerned about them being easily phished from users or replayed as other types of transactions. And there's now a kind of context variable for whether or not an account has authorized the current calling context. Excuse me, let me drink some water. I'll explain that in a second, but basically there's a possibility of an address being available. I'm not going to read all of that. What I'm going to get to is I'm going to get to the two new opcodes. We're going to have two new opcodes. Is this the... no, too far ahead. All right, we're going to have two new opcodes. There's auth and auth call. I'm sorry. Let me find the beginning of it. Oh, so we need auth first. Sorry about this. Okay, yeah, so we introduced auth and auth call. Auth is going to take a signature in a certain format, and it will, if the signature is recovered appropriately, it'll assign the signer's address to the authorized variable. So that means, and then auth call will allow the contract to send a transaction on behalf of the authorized address. So let's, I'm trying to keep it not too low, but get just at the level that'll be useful to you. So let's jump to, I think the diagrams are pretty good. So here's a hypothetical auth message format. So remember, we've got a magic prefix. This is like the 0x3. And then this is theoretically the invoker address. This would be the address of the contract that you're sending this message to. So from now on, when I say invoker, I'm going to be referring to the contract that you're trying to delegate your account power to. So in this case, we're looking at the simple meta transaction case. So let's imagine we want to add meta transactions to all accounts, all MetaMask accounts for all contracts. What we would do is we would have a contract that is able to interpret this message type right here. It'll take, anyone can sign a message. It's got the prefix. You specify the invoker. So these signatures are only good for this invoker. So if you've formally verified this meta transaction invoker, then you're very confident that if you sign this prefix and its address, that it's going to do with your commit as it was programmed to. The commit is just some bytes, but you can use it to store a hash of more data. So in this case, the commit is committing to basically transaction parameters. So this message here is just enough for me to submit an intended transaction, but as a signed message. So I don't have to send this with gas. I could hand this to somebody else. Somebody else could submit this and then send this to the invoker. The invoker will now take this message. It'll check the byte. Oh, so sorry, the invoker doesn't check the message. The invoker invokes the auth opcode. The auth opcode will now check. It'll say, okay, you've got the byte. Yes, you are the contract that this message was signed to. The auth message actually doesn't care about the commit. And so then if the other two were correct, the auth opcode will now assign the caller's, the signer's address to the authorized parameter. And now it's up to the invoker to do what they want with this commit hash. So you can imagine that the first parameter for an invoker is this whole signed message, and then it's got subsequent parameters that refer to whatever's hashed in the commit. So there we go. We've got a framework for a very simple meta transaction contract. And right. And so then once that authorized value has been assigned, now this invoker is now able to perform the second operation, which is auth call. Okay, it's interpreted the same as call, except that if authorized is unset, it's invalid, and otherwise the caller is set to authorized. So we've got a way now. And when we say caller, we're talking about message.sender. If you write Solidity contracts, you recognize message.sender as the thing you check usually to see who's invoking this method. If you're sending a token, you're probably saying, okay, send the token from tokens at message.sender's account. So now we've got a way where this contract, this invoker contract, is able to send transactions that look to other contracts as if it was sent by your key. The gas cost is specified in the gas cost section. So this contract still has to pay its own gas, right? So whoever's sending to the invoker still has gas burden. If gas available for the subcall would be less than gas, then it's invalid, of course. There's no gas stipend, even for non-zero value. I'm not sure what that means. Okay, we don't have to read the whole thing, but yeah. So it's basically just like a call.
Dan, would you be able to bump up the resolution of that, or maybe the size? There we go. That's perfect. Yeah. Thank you.
Cool.
That helps to read it. Okay.
Sorry about that. Yeah. So anyway, so in short, auth call is just like auth, except the caller gets set as authorized. All right, I think that's okay. So let's look at a couple other use cases. So I showed you the meta transaction use case. Another use case might be multi-call. This would be a batch transaction. A lot of times people, you might want to save gas. Every transaction you send has a base cost of gas that gets applied to the front. So you can save a lot of gas if you were able to batch transactions. Well, with an invoker that supports batching, all we would have to do is see it, formally verify it, and then have wallets that support signing messages in this format. And so now you could queue up a bunch of transactions. You could imagine a DApp that says, approve my gas, then invoke the trade, and then you can use that token to stake or something. And so you could do all of that in a single transaction now, because you can have an invoker that you sign a message to that knows how to interpret, that format of commit. So yeah, let's get into what did I want to go to next. So that's the basics of it. Let's maybe briefly talk about the security. So the thing is, a lot of people were saying, hey, this sounds terrible. It sounds like you're there's actually a meme that this was like using sudo. This is like sudo. Like everyone's going to be authorizing these invokers and they're going to have full authority over your account. That sounds terrible. You shouldn't do it. It sounds like an anti-pattern. We need to audit this more carefully, etc. And don't get me wrong, we should audit all protocol changes very carefully. But I don't think this is anything like sudo. So let's just look a little bit at why it's not like sudo. Okay, so let's first just imagine an account with a bunch of different assets in it. In actuality, each one of those assets is not in your account, right? We know, because we're Solidity developers or whatever, EVM developers, that really each one of those assets is represented by a different contract that is making a reference to Alice's account, right? So when she's interacting, when Alice wants to interact with one of her coins, she's actually calling a message to one of those coins, and it's checking if it's from her account. So an allowance, so she wants to grant an allowance to the DEX. This line that's representing her account, it's actually an abstract thing. It represents control of those assets, okay? So what she wants to do is she wants to take her control of this asset and she wants to grant a limited allowance to Bob DEX. Now notice that this is not control of more things, right? So an allowance is a nice safe little thing, and we do this all the time. And this is an app layer thing. And if we do it right, you're only granting an allowance that's close to what you actually want to risk. That's like the security principle of least authority. We want to minimize our risk. So we want to just, if we don't trust this DEX, we want to put the smallest toe in the water. All right. So the thing is, okay, people think that it's kind of like sudo. Like every time you interact with the DEX, does it mean that you're giving everything to it? I say no. That's what sudo is. When you call in a Unix system, if you invoke sudo on a script, you are telling that script in the system. You're telling the system, let the script do literally anything it wants, right? So that script, it can encrypt your hard drive, and it can, read all your files and send them home, and it just absolutely anything. And I would absolutely not ever endorse, a model where people do that with DEXs. And that's basically what people did back when they used to, early, basically pre-MetaMask. What people would sometimes do is, a DEX would say, hey, upload your private key. You upload your private key, now you can do anything, right? And it's very convenient. It's not very safe. So we don't want to do that. Instead, what I propose an invoker is a little bit like, it's not an external agent that you're delegating everything to. You should think of an invoker as part of your broader wallet. So your keys are now, they're a part of your wallet, and it's the part that conceptually controls your assets today. But what 3074 lets you do is it lets you take your keys and sign a message that basically blesses this contract as part of your broader wallet. And there were people saying, oh well, you just want this because it sounds like wallet convenience. It's like, no, I think that maybe I'm more comfortable with the concept of adding code to a wallet, because as a wallet developer, we add code to a wallet. We know it's sensitive, we know it's careful, but we know that it's also something we have to do to meet user demand. So here in this case, what we're doing is now we're adding a portion of code, and it's as small as a single feature at a time. And so rather than needing to opt into a whole contract wallet framework at a time, we could literally say, okay, I'm going to sign a message to add batching support to this wallet. So this could either be done by the wallet team themselves. The wallet team could basically just expose an API method that lets you batch, and then wait until you try to batch transactions, and then we can just sign to a trusted invoker then. So the wallet could ship with the trusted invoker hard-coded. And so by being reviewed and blessed by the wallet team, it has effectively the same security model as any code update to a wallet has today. And then, so once you've got a batch invoker, Yeah, it's still setting allowance and it's performing trades. So it's doing a lot of stuff on your behalf. But it's still doing these things according to the rules that were blessed. And so assuming that this was reviewed carefully, it's still adhering to that principle of least authority that we strive for when having users interact with contracts directly. So that kind of shows how I think of invokers and their security properties. Oh yeah, and then I briefly talk about, it's like we literally think about principle of least authority all the time. Small lava moat plug at MetaMask, we're working on this great JavaScript library that lets you confine all of your dependencies. Because today, all of your dependencies have access to your whole system under your user account. They can install scripts on install time, and that could undermine all the software that you distribute, from the contracts you write to the interfaces you ship. So consider checking out LavaMoat. You add it to your bundler, and it will wrap all of your dependencies in confined scripts, so they can't do more than you ask them to. Okay, so it's kind of side-related thing. All right, so now let's just talk briefly about possible use cases. Okay, so we talked about batch transactions, and we touched about meta transactions. Another cool one is multi-nonce. Multi-nonce is this cool idea from I first heard it from Patrick McCrory over from the Infura transactions team, or any sender formerly. And it's a model where you basically have a two-dimensional nonce. Instead of your account having a single nonce number where it's like, okay, your next transaction has to be 1, next transaction has to be 2, and which can lead to situations where you have a low priority transaction with a low gas price blocking a higher priority transaction. Multi-nonce would allow you to have multiple queues of transactions, and so you could have lots of stuff going on at once. You could be placing a bid on a low stakes thing over here. You could be sending someone a little bit of your favorite token over there, and then also executing a high urgency trade right while those things are pending. And these things are all composable. So you could very easily have a situation where you've got a couple transactions that are queued and waiting for a low gas price, but then you batch something else and get it done, and this is all getting paid for by somebody else. This allows contracts. This is kind of a bigger, almost abstract concept, but there is an opportunity for a verifier to abstract more off-chain signature verification logic. So an example would be like DAI v2 introduced the permit method, which allows allowances to be set with an off-chain message, right? And so that's really great because it's one less transaction that you have to sign in a lot of situations. But it'd be great if more methods had that kind of thing. A lot of contracts today are submitting, they write their own custom off-chain message verifier for a lot of methods. OpenSea does this for their bids, because you don't need a transaction for a bid. You just need a transaction to accept a bid and complete the trade. If we had invokers that were very meta transaction friendly, your bid, rather than signing a bid that was designed for that contract, you could sign an invoker transaction that basically says, I would bid, so the auction contract author could just write a bid function, just a regular bid function, as if it was all on chain. And now I could write a invoker message that says, I would bid, anyone can submit my bid. And now the person who wants to settle the bid, they can now batch together somebody else's message that submits their bid along with their own that accepts the bid. And so what we've just done is we've taken all this like off-chain signature verification logic, taken it entirely off the shoulders of the Solidity developers. Solidity or EVM developers could potentially just be writing the functional definition of their contracts, and at the application or the UI layer, we could be handling all the stuff like how do we utilize invokers to optimize as much of this to be off-chain as possible. And then I'm starting to get into the fun, crazy stuff, but I don't know if any of you are familiar with link drop. I think things like link drop could be also done more easily and trivially. So link drop is it's another way of signing an off-chain message that you give to somebody as kind of an invite link. You say, hey, here's a link. It's a right to claim some ether. So, you can imagine It's a combination permit method permitting a account that's controlled by a private key that you're including in the message. So you give somebody everything they need to redeem some crypto, and that's a really cool feature. But that would only be supported by a contract that has an allowance for a token, and so you have to do all this on-chain stuff to set up a link drop. These days with the gas prices like they are, we should always be looking to minimize on-chain transactions as much as possible. And so one way we could do that is, hey, what if every single allowance you could ever grant could be represented as an off-chain, invocable message? And so you could assemble an arbitrary set of permissions and capabilities. These could represent the ability to invoke specific functions on your behalf. And you could bundle those into a single message, send them to somebody who doesn't even have an account yet. It could be wrapped as an invite code that onboards a person and gives them everything they need to get started participating in your ecosystem. I'm really excited about that kind of onboarding experience. It could even include, a permission to pay gas from your relay. Remember that one of the original use case was meta transactions. So permission to get your gas paid for you seems like a really obvious thing to include in an invite link ecosystem. And then there was a question about, are these permanent delegations to these invokers? Could we make it even more secure? This was a fun conversation that came out of an internal conversation at MetaMask. And, would we need another opcode? Should we have a deauth code? And then on further consideration, we realized that actually you could optionally make invokers themselves. You could either make an invoker revocable, or you could actually have a second type of invoker that is a revoker contract, and you could basically use it to delegate to your invoker contracts. I almost need to step through that again. There's a way you could basically, even using using invokers that weren't designed to be revocable, you could basically wrap your access to them with a revoker and be able to revoke it. Anyways, that's getting a little out there. That's kind of a fun thing, but my point is I don't think we need another opcode to add revocability. I believe it can be composed in AppSpace. All right, so let's just hop back. Oh yeah, how can MetaMask accelerate this? I'm just going to briefly talk about, so the security model we were talking about is like, okay, how do we get invokers in contract or into wallets? Well, I said we're not doing it. We're not doing it at dApp time, right? This is not something users should be doing casually. That'd be unacceptable. This is a security critical thing. Invokers have to be treated with the utmost respect. So the obvious and safest thing we can do is basically just formally verify the heck out of these. This could be the kind of thing where, we make a wallet DAO, or we just make it public and we just, we crowdfund formally verifying each new one. Really, the low-hanging fruit are big enough as they are. If we get batching, meta transactions, and like you pick two of them, and the multi-nods, that's huge, right? Those three, it would just solve so many user experience pains on their own. So it might be that we get those written, we verify them really well, and we integrate them into the wallet really, really wonderfully. But we are at this weird, awkward, growing pain moment of history where people are ready to start writing these invoker contracts, but integrating them into the wallet is still awkward. So, for example, we might have people even in here now who, the ITX team wrote some invokers like really fast, because the ITX is itself a meta transaction relay service. So they basically had all this code ready. They just had to use 2 new opcodes on a test net. But the question is, okay, now how do we try it? We have to integrate into a wallet. And so that's when it becomes a serious current wallet responsibility to make this integratable. So we can collaborate, and I do think that might just be itself a great hackathon project. And so that might be itself, maybe we do that for hackathon. Also, though, I think that there is an opportunity that we could support adding invokers to our Snaps beta. For those of you who are familiar with the Snaps beta, MetaMask has an extensibility system that allows us to add, basically small JavaScript modules that have limited permissions. and add those to the wallet at runtime. So we could add special APIs to our Snap system to specifically enable this. We could enable proposing a transaction to the user, propose adding a token. Oh, wait, by URL. API method invocation. Oh, sorry, that's actually not the one that I thought it was. Excuse me. Okay, I'm gonna have to describe what that would have been like. 3074. Opcodes. Do I have a good example of it? Oh, here we go. First, add that options. Oh, no, I don't have great notes on that yet. Okay, I'm sorry. So this is a little bit of a stub. I think we could do it. I think it'd be a hackathon project. I think we would want a permission to add invokers to the wallet. What does that look like? Well, obviously an invoker is a critical thing. It would have a horrendous warning, and this is just in our like developer beta, but it would be having a special build of MetaMask somewhat for invoker developers that allows quickly kind of plugging in invoker code without having to rebuild the entire wallet. And if we manage to make the consent process high friction and safe enough, I could perceive or imagine us exposing it in some more live context. I don't want to say we would ship it to production yet, but depending on how we built it, I wouldn't totally rule it out either. So you could imagine permission to add invoker. What does an invoker do? Well, it wants to be able to show confirmations that look like Ethereum transactions. It needs to be able to access your key because it's going to at least well enough to sign invoker style contracts. In fact, we can restrict that permission right down to the format of the code, right? A given invoker only needs to be able to keep variable this part of a signature. So you could hard code, an invoker would ask for permissions to delegate messages to a known invoker address. The confirmation could even review that invoker's address. You could verify it on Etherscan. So if it had permission to sign in that format and show confirmations, maybe with some customizable template space, we could probably make a pretty open-ended, extensible invoker wallet system. Anyways, that's maybe a little further out there into the wallet sci-fi than the average one of you is thinking, but throwing it out there as a possible hackathon project.
Okay, Dan, we do have a quick question.
Yeah.
I'm not sure who this is coming from because it doesn't say. Oh, Andrew. He was wondering, how is this functionality different from having a multi-signature or a multi-sig with just one signer? Does that make sense?
Yeah. Well, a lot of ways. I mean, the simplest way is just it works for all existing accounts today. Like if this rolled out, if we supported this, then you could do that today, and it's very similar. And maybe that's just like annoying wallet migration path, but I think that more people probably should be concerned about that. Like, what does it look like to build a dApp where some people could have contract accounts and some people can have keys? Like, I think that it's a lot of developer overhead. What this lets you do is it puts more of that logic over onto the wallet side. Users can have key-based accounts initially. Users who had key-based accounts can now benefit from all of these features. And and then dApps still just have to implement functions and expose them. And then another way is an invoker actually could delegate to more than a one-of-one. So you could, for example, let's say you've got a seed phrase today with 10 accounts. You could sign a delegation message with each one of them to delegate to an invoker that is itself basically a contract account, and then you could throw away the key. And then you've actually upgraded existing externally owned accounts into contract accounts, and they could be more than one-of-ones. They could be whatever combination you want. So you could treat this as a way of escalating keys. So this EIP definitely only makes sense when you take it in the context of most people are using externally owned accounts today, and we want to have a nice migration path where we can benefit from all the features of contract accounts and account abstraction.
Yeah. Do you see what Andrew has said? So he said,
says,
yeah, you can read that.
So I could do something like Argent Vault with this auth opcode into a Vault Invoker contract. Yeah, Argent's a contract account that has a variety of features. One, let's say, is account recovery. You could we could have an account recovery invoker. So you could sign a one-time message that says, if these 3 people sign a message, then they can assign a new key that's now able to sign messages from my account. So it's still your same address, but you've actually got a new key now that's able to sign transactions on behalf. And you can make that arbitrary. You can make that revocable. Yeah.
Nice. Thank you.
Yeah. So, I had a couple other possible hackathon projects. What was it? Oh, yeah. Writing new invokers, modifying MetaMask to do it, to support that. Oh, yeah. Okay. I said these 3 things. And then the Snaps beta, extending it to support adding invokers. Yeah. So those are the 3 kinds of those ideas. So that basically takes us on to the Q&A. So we can just kick into just general discussion. This is a really big topic. So it really gets into like, what do you want possible with your accounts?
Can you hop back to that slide that you just had up, though, where it just was like the bullet points?
Yeah, this guy.
Yeah, that, and the other one. What was that? The other one you were saying? Were those
possible
like talking
hackathon projects? Or
yeah, was that what it is? The one that the slide just before that one.
Yeah, this.
Yeah, so this was just an extension of that one.
Yeah.
So yeah, the MetaMask Snaps. Like, can you talk more about that?
Yeah,
like, the situation there.
Yeah, so MetaMask
I feel like that needs a bit more exposure. It's a really exciting thing.
Okay. Yeah, so let me just show you a little bit about one of the projects we've got going on at MetaMask. This is it actually had to be kind of on ice for like the last year, but we're putting a lot of fresh energy into it right now. So it's firing back up. This is basically the MetaMask plugin system. You can I'll put this link I'll put it in the chat right now. But yeah, you can. Thank you. Yeah, I mean, it's a really big topic. The talk we gave at DevCon 5 was about this, and I think it's really awesome. It was motivated by basically trying to make a permissionless ecosystem where the wallet is currently maintained by a single team. There are a lot of ways that, the whole beauty of Ethereum is that it is a general purpose computer and that it allows anything to be done. But ultimately it's only as useful as the interfaces we use to interact with it. And at MetaMask, we kept finding new features new ways people wanted to use Ethereum that depended on us to do them. I mean, don't get me wrong, you can always like make a dAppt interface with any contract, but some of these contracts are made to be, abstractions that are like meant to be kind of part of the wallet. So like a new token standard, new kinds of ownables, our desktop client still doesn't have collectibles. Sorry, coming soon. And then contract accounts, support for layer 2s, that use alternative cryptography, things like Starkwares and snarks and stuff like that, and privacy preserving things. Shouldn't you be able to hold your Tornado Cash in your wallet, for example? So being continuously faced with the dual horns of maximizing security and shipping features faster, I think we were just put in a context that made us hyper aware of what is the most safe way of extending something. And so that led us to a framework of security that involves confining things by permissions. And it actually exposed us to the work of Agoric that has a project called CES. It's a tool for confining JavaScript and giving it limited access to objects. I actually have another talk as part of the hackathon series about CES and about how to use it and kind of that whole ecosystem, because confining JavaScript is cool, but what's even cooler is having like an extensible, collaborative, distributed substrate for computing, and that's what I think this builds towards. So we're gonna let you extend your wallet, and it'll let you add new blockchains, and it'll let you add contract accounts, and you can try the beta today. But eventually, it'll also let you escalate some scripts to other computers to share capabilities with your friends. I think it's a really exciting path, and it's going to take a while to do right, but we are committing continuous effort to it to get it done.
Love that. That's very exciting. Yeah, absolutely. And I think that's so important to like listen to what everybody is like hoping for, so you can give the context, because you're right. It's only as good as the use case or the context the technology is, So I love that MetaMask is doing that, and I think that's it's going to be really exciting. You're addressing a lot of pain points for sure. So I love that. And this is beta right now, so it's available to use, you're saying. However, you're still working out features. Is the idea that you want people to kind of use this so you can help fine tune it? We're in this beta stage, so forgive the little flaws as we kind of really make this amazing.
Yeah. So it's this is an awkward time to be promoting it, because we're actually making some big exciting changes right now. And if you were watching the code base, you would have noticed that in the last few months, we were able to synchronize our classic beta with our upstream. So it is up to date with the latest MetaMask. So it is currently a current version of MetaMask that's extensible. But we're working on making it easier to consume for developers so that we can we're going to get it more usable and more useful soon, possibly even in a store or something, so you can try it out. But yeah, we're still in a phase where we're going to be trying it out a lot. We're probably going to be breaking the APIs a lot. I would really mostly recommend it as a kind of conceptual exercise for now. I wouldn't advocate anybody like bet their startup on it just yet, because we might ship a little later than you're planning to. But if you want to see what we think is possible, I think it's a really exciting paradigm, and I think it's on its way.
Absolutely. That's great. As Dan said, if anybody has any questions right now about what we discussed today, the Invoker contracts, about wallet UX, which is really important, anything about what he just mentioned about swaps, snaps, swaps, all the things, all the good stuff that MetaMask is doing. But you are welcome also to come on stage and pop your video open and ask the question yourself if you're interested. We can do that, but just let us know in the chat. The only other thing I could think of, Dan, is like, is there, for this subject in particular, you mentioned why you were so excited about EIP 3074, in particular, like your interest level. And what are the main takeaways of this talk today that you can kind of share with everybody? And by the way, if anybody wants to take this conversation, maybe we're, letting it all settle in, and later you think of something, please reach out to Dan on Slack. Correct, Dan? I'm assuming you're available if you have any other questions to follow up with this stuff, and feel free to kind of continue the convo there too. But if you are, what do you think, Dan? What could you impart to the audience today about this particular topic?
I mean, it's a cool proposal, because I think that we've had ways of trying to address generalized meta transactions and generalized batching and account abstraction and execution environments for your account. These have been things there have been proposals about for years, and so kind of big props to the authors of this one for coming up with a solution that was kind of so simple. I really think that Matt Garnett and Sam Wilson did an amazing job here. Some of ConsenSys' own, and yeah, so if you could take one takeaway away, I think it's like the security model of like, look, delegation. Delegation doesn't need to be scary. It needs to be done carefully. You have to think about it carefully, and it's really a recurring theme in the things I've talked about. Actually, when I mentioned Lava Mode earlier, Lava Mode is built with the same SES confinement tools that our Snaps system is built on, and it's really the paradigm of delegation. It's a magical thing. If you can get that paradigm into your head, it's like the atom. It's the shared electron of security, right? Like you want to make two things interact. Well, something's going to have to be prone to the other contract. So make it as small as possible, the principle of least authority, and be deliberate about that, right? So Don't treat it like it's just some random every dApp gets everything. Make it a deliberate act. Make it a considered, reasoned extension of what you're building. And anyway, so that framework as a way of assessing security, I think, is very useful. I think it's a great way of thinking about this EIP. This EIP has incredibly just 2 opcodes. Basically delegation and then using delegation, right? Those are the opcodes, and it's such a simple pattern, but it makes so much possible. So I hope that what you take away is, hey, I can write new wallet features for every account. And that's cool and exciting. And so anyways, I'm very eager to hear the ideas that everybody comes up with, both here and in the wider ecosystem.
Yeah, I love it. And we do have another question coming in from Andrew. Did you want to jump up and ask the question to Dan? I don't know. I know sometimes it's just easier if I ask, but you're welcome to join. You just ping me on Slack real quick. If not, I'll just ask the question for you. Well, basically he's asking, he didn't. I'll invite you on. Here, I'll go ahead and invite you in to ask your question. Let's see how this works. You should get a little invite if you accept, Andrew.
Oh,
there you go.
Working.
Welcome. Hey, Andrew.
Hey.
Good to see you.
Hey, how's it going?
See you. Yeah, I was asking about like snaps versus swaps. Just trying to understand like when is there a decision to kind of create an like aggregation like integration like swaps versus like focusing on just giving developers or dApp developers the tooling to build their own integration style. Like, will the future of wallets be like, all right, we're going to focus on kind of this integration marketplace on one side, and then EIPs for like wallet RPCs and opcodes on the other? Because I see like other wallets, for example, like Rainbow, are very focused on like just building out in wallet, kind of like custom dApp interfaces. Right, whereas like MetaMask, it looks like it's taking like the opposite side of approach. So I'm just trying to better understand like the thought process there, if that makes sense.
Yeah, that makes perfect sense. I think you said it really well. In my opinion, like I said earlier, like Ethereum is interesting because it's extensible, and I do think that there's a lot of room to optimize current experiences, and and we're getting better at doing that. And actually, partly in thanks to the swaps revenue, we're staffing up in ways. So actually, for the first time, I don't think that we're making a total trade-off between those two. We have a team that's building towards snaps, and there is a team that's building swaps. And
right.
So fortunately, what I think we're in the space of is I think that MetaMask still does. I think of all the wallets, I think we value community contributions more than any other wallet. That's my opinion. And but I do think that I think we're getting better at then identifying when those community contributions have gotten so mature, like dexes, that it's like, okay, let's make this easier. We were slow on tokens too. I don't know if you remember this, but like we were like, we had a huge backlog, and people were like, put tokens in the wallet, and we just didn't for a long time. And people don't think about it anymore because they're like, oh, it's obviously a feature of every wallet, but actually everything's still usable without tokens visible in your wallet. You just go to a dApp to look at your tokens, right? Like Ethereum and Zapper or whatever. So I think it's actually okay to be a little slow on the like final polished integrations. Obviously, it's really great to have those experiences, but I think that they'll be more and more obvious how to do those right after everyone's had time to experiment. I don't think we should prematurely optimize for like saying we've got everything right. I think, it's like we could make a perfect NFT gallery today, but the gas prices are still astounding. Like, shouldn't we be looking a little bit more at optimizing, like, keeping more stuff off chain, keeping stuff more multi-chain, making it easy to add new custom local chains and state channels and stuff. So I think we've got a lot of infrastructure to go. And so yeah, things like Snaps shows that we're continuously betting on community ingenuity. And then we'll take the best stuff and we'll try to make that into polished experiences.
Right. Great. All right. That answers my question.
Awesome question, Andrew.
Cool.
Thank you.
Yeah, great question.
Appreciate it.
Thank you.
Okay. That was thanks, Andrew, and I appreciate you coming up to ask the question too. It's always good to see you guys' faces. Let's see here. I think I don't know. See any other questions? You really did cover a lot of great stuff, Dan. Thank you so much. Yeah, and again, like you can continue the conversation on Slack. We will share those slides as well. And can you put it to the very last slide there, just so we can kind of remind everybody. Thank you. And so, yeah, again, like this is an ongoing, iterating, evolving topic, as Dan mentioned. This is really great for you to give us the insight on what you guys are working on and why. I think that's great to, figure out like where the focus is going to really land once you kind of see, we're paying attention to the pulse and the demand. So that's important. We want to support our developer community and make sure that everybody has the tools or feels the confidence to kind of build some great things. So yeah, please continue to follow us on, if you're not already there, on the Slack channel, ConsenSys Hackathon 2021. That's where we'll be posting all the replay links to this workshop as well as the slide decks. And then you can RSVP for more workshops that are available. And of course, you can sign up for the hackathon. Dan mentioned that there was, the great idea he went through. Is there any, did you want to maybe recap that one more time, Dan, about the hackathon project that you had mentioned?
Oh, I had a couple ideas, but one is just like, if you want to try writing invokers, try to write invokers. Patrick McQuarrie here at ConsenSys has already written one, so he probably has some boilerplate code you could use. And then secondly, if you want to then give those invokers an interface, come talk to us at MetaMask. I think that would be a really cool project. And really, I didn't mention like the timeline of this. They were trying to get it in as soon as the London hard fork. It's likely that's not going to make it, but it may get into a special smaller hard fork before the proof of stake transition. And so it may be as soon as like October. But of course, these features won't ship in wallets in October unless we figured out the UX around them. So I think if we did a little hackathon thing where we actually experimented with getting some of these into the wallet, I think it would make it much more likely to deliver these a little bit sooner.
Exciting.
So anyways, reach out if you're interested.
Love that. Love those ideas. And yeah, exactly. And who was it you said to reach out to in terms of the first idea, or besides yourself?
Patrick McQuarrie is doing a lot of the contract stuff. Yeah, I would look to the MetaMask team when you're ready to get it to the user facing side of it. But yeah, Patrick and Chris over at ITX are doing great work on the contracts.
Awesome. Okay, so definitely reach out to Dan if you're interested in this idea. I think this is a great idea. And the hackathon week, which is June 7th through the 11th, this is a 5-day sprint where you can basically vet your idea, really kind of like expedite giving it some legs. And then if it has to do with this, MetaMask team will be able to kind of determine if this is something that could be, it could be a new enhancement feature for our product, which would be very exciting. All right. Well, thank you so much, Dan. I really appreciate this workshop. Again, wonderful content. And hopefully everybody enjoyed this as well. Thank you again for joining as well. And hopefully we will see you on the next workshop that we have available. So, and please sign up if you're inspired. Andrew, I don't know if you've already signed up, but definitely let us know you're interested in hacking, because we're doing team building sessions starting already this week through to the end of this month. We'll help you put together your team if you have an idea, or if maybe you just want to hack on an idea that is available. You don't have the idea, but you want to offer your hacking talents, then we'll help you get to the right team and the right idea so that you guys have a chance to win some cool prizes. And potentially be, creating something awesome for the company too. There's that. So, all right. Thank you again. And we'll see you next time. Okay.
Cool. Thanks a whole lot.
Thanks, Dan.